we are going to see some of the properties of homomorphism. So, to begin with, let us consider two groups G and H, and F is a homomorphism from G to H. Then the property says that F always map identity element to identity element. That is, if EG is the identity element of G and EH is the identity element of H, then the homomorphism F will map EG to EH. The second property says that homomorphism map inverses to inverse itself. That is, if A is having image f of A, then the A inverse will be having the image f of A inverse. The last property says that homomorphism maps powers to powers itself. That is, the image of A raised to n is equal to f of A whole power n. We will see the proof one by one. First one, homomorphism maps identity to identity itself. So, we will start from the left side. We always know that any element taken with identity element gives me that element itself. So, here I have taken f of Eg. F of Eg star Eh will give me f of Eg. Okay, here f of Eg is an element of range, so that I have used the operation star and used its identity. Please put that in mind. Now, Eg can be written as Eg.Eg because Eg is an element of domain and the domain is having the operation dot. Now, since f is a homomorphism, I can have the split f of Eg star f of Eg. Now, if I cancel f of Eg in the left side and the right side, I have the result Eh is equal to f of Eg. This is the very simple proof of the first property, that homomorphism always map identity to identity itself. Now let us go to the second property, that homomorphism maps inverse to inverse itself. For that I am considering A and its inverse. Clearly A dot A inverse will be Eg because A and A inverse are elements of domain and there the operation is dot and identity is Eg. Now I am considering the image of A dot A inverse. So f of A dot A inverse is equal to f of Eg, which is equal to Eh, because from the first property, identity element is always mapped to identity itself. Now, due to homomorphism property of f, I can split the left side as f of A star f of A inverse is equal to Eh. So from this equation, it is clear that f of A and f of A inverse are inverse of each other, so that I am getting identity element. So the inverse of f of A is f of A inverse. Now I hope the property is clear to you. Now the final property is very simple. Just by applying the definition of homomorphism, I can easily get into the answer. So I need to find the image of A raised to n. So I will take f of A raised to n, which is equal to multiplying A n number of times. Due to homomorphism, I can write the answer as f of A star f of A star etc. n number of times, which is equal to f of A whole to the power n.